Okay, so before we get into this data grade, I want to address these three equations, okay? So all three of these are used kind of as sort of the same thing. The difference is these two here specifically find MTAN, okay? And you're finding only MTAN. If you use these two, you will not find the derivative. Okay, you're only going to find MTAN because you're plugging in A in the front end instead of the back end. Where like this one, you're going to find the derivative, the general derivative first, and then find f prime of A, and then plug A in on the back end, and then that at that point is MTAN. Okay, so that's the difference in these two equations. Personally, I like to stick with this one all the time. I'm going to find the derivative first and then plug in A. The reason that I do that is because it's so easy to mess one of these two up, to plug in wrong, plug in the wrong place. And notice here, this is x approaches A instead of H. So this one is similar to the first one, but then this one is you're plugging in A, and then you're taking the limit with respect to x. So it's very, very different. So it would be very easy to get confused or do the wrong thing when you start switching formulas. Now, you may have a professor that specifically wants you to, they'll start here, and then they'll go to this equation, and then lastly, you'll find your general derivative and plug in A on the back end. Okay? I just prefer, when we're starting out here in high school, just to stick to the one here, and then just use it across the board, because that way you'll be super comfortable with it. And then second go around in college, when you get there, these formulas will be easier to interchange because you'll be more comfortable with the first limit definition of a derivative. Okay, so the instructions for the problem say to find the derivative using the limit definition. So we know for the limit definition, we have the limit as h approaches 0 of f of x plus h minus f of x all over h. So we have f of x, obviously, so we need to find f of x plus h. So that means everywhere I see an x, I'm going to replace it with x plus h in the original function. So I have 2 times x plus h squared plus 3 times x plus h minus 4. Okay. Now, I like to expand this before I put it in the problem, just because I don't like to have to carry that over and over and over and over through the problem. So I have 2. Remember, when we expand a binomial, it's the first term squared, twice the product, last term squared. Then I'm just going to distribute. And then the last thing is distribute the 2. Okay, so now that I have that, I can come back to my limit definition. And I have that equals the limit as h approaches 0. So f of x plus h is this long thing here in purple. We have minus the function, so make sure that you use parentheses. Without parentheses, you're not going to distribute the negative correctly. So now that we have it all, we know the next thing that should happen, especially when we're using the limit definition or the difference quotient with a polynomial, is the whole second half should go away. So I have 2x minus 2x, 3x minus 3x, and a negative 4 minus a negative 4. So then that gives me the limit as h approaches 0 of 4xh plus 2h squared plus 3h all over h. And then again, especially with polynomials, we know that the very same thing happens for every polynomial. The f of x disappears and then the h disappears. So h or factors out, and then this goes to a single h. So that gives me the limit as h approaches 0 of 4x plus 2h plus 3. And then at this point, we're ready to evaluate the limit. So we have 4x, because it's a constant, because we're taking this limit with respect to h, and then 2 times 0 plus 3, and we have now 4x plus 3. Now at this point is equal to f prime of x. Now at this point you should, now that we've learned how to do shorthand derivatives, you know that this is the derivative of the function. So we brought the 2 down, 2 times 2 is 4x, and then the 3x goes to just a 3. So now you know how to check that. So when you get on your test Thursday, or your quiz Thursday, you'll know how to go back and go, oh yeah, this is the derivative, or you'll know, I did something wrong because this is not the derivative of that function, okay? So fractions are another super common problem with when they were wanting you to find the derivative with a limit definition. So we have the same thing, the limit as h approaches 0 of f of x plus h minus f of x all over h. And so I would find f of x plus h first. So that's 3 over x plus h minus 1. So then we're going to plug in. So we have f of x plus h minus f of x all over h. Now anytime you have this, it's kind of the same process over and over again. Now it may vary a little bit. The what you do or what you multiply by is obviously going to vary. But when you have this fraction within a fraction, you have this complex fraction set up, you're going to do the same thing every time. You're going to multiply everything by the common denominator and just make your life a lot easier. So I'm going to multiply by x minus 1 and x plus h minus 1. X minus 1 and x plus h minus 1. And remember, you have to do this to every term. So x minus 1, x plus h minus 1. So then I'm going to cross out what goes away. So that gives me the limit as h approaches 0 of 3 times x minus 1 minus 3 times x plus h minus 1 all over h times x minus 1 times x plus h minus 1. So then we need to simplify. So I'm going to multiply the top, 3x minus 3 minus 3x minus 3h plus 3 all over h times x minus 1 times x plus h minus 1. So we have then a 3x minus 3, a negative 3, and a positive 3. So that's going to leave me with the limit as h approaches 0 of negative 3h all over h times x minus 1 times x plus h minus 1. And we are ready to evaluate. So we have, or we're not ready to evaluate, that's not true. We need to get rid of these h's. So I have the limit as h approaches 0 of negative 3 over x minus 1, x plus h minus 1. Now we're ready to evaluate. And I get negative 3 over x minus 1 and x minus 1, which is negative 3 over x minus 1 squared. Now, you could do either quotient rule or product rule, bring this up as x minus 1. Well, you can't do that yet because you don't have chain rule, but you could do this as quotient rule and you would find you would get the same answer. You should kind of see this a little bit in that this is low squared. That's the denominator squared, and you know that's part of the low d high minus high d low over low squared formula for quotient rule, but you could go to the side and double check that you did this correctly. So for number 3, it says to find the slope of the tangent line at the indicated point. Okay, so we're going to find m tan given the point. So you can do this one of two ways. You can either go ahead and find the general derivative and then plug in negative 1 at the end, or you can plug in negative 1 at the beginning. But since we're using the limit definition, and that's what our quiz is on, and that's, like I said in the very beginning of the video, where I focused, that's the one I'm going to use. You don't have to. You can plug in A and use one of the other two formulas. It's totally up to you. So I have the limit as h approaches 0 of f of x plus h minus f of x over h. And I will use one of the other formulas later on. Maybe that would help as well. Okay, so f of x plus h is going to be 3 minus 2 times x plus h, which is 3 minus 2x minus 2h. Okay, so this is going to be the limit as h approaches 0 of 3 minus 2x minus 2h minus 3 minus 2x all over h. So we have a 3 minus 3, negative 2 minus negative 2, and that's going to leave me with the limit as h approaches 0 of negative 2h over h, which is just the limit as h approaches 0 of negative 2. And the limit of a constant is the constant. And there's nothing for me to plug in. That means that every single place on this line, the slope is going to be negative 2. Now, I want us to think about this. Okay, so the derivative of a function, okay, evaluated at a point tells the instantaneous rate of change. But linear, this is a linear function. What's going to be the slope of a linear function no matter where you are? It's the slope of the function, right? Y equals mx plus b. Well, what's the slope of that function? Negative 2. So the slope is going to be the same no matter where you are. That's why you get a constant for a linear function, because the slope is constant. The slope does not change, so there's no variation in the slope. So there's no place for you to plug an x in. The slope is the slope, right? Okay, so I decided to go ahead and redo this problem using the actual MTAN definition. So that would be the limit as x approaches a of f of x minus f of a over x minus a. So basically this boils down to being a slope formula, right? 1y minus f of a's y, or a's y, f of a, and then x minus a, that's slope. Difference of y over difference of x, which is what the limit definition is. That's what the difference quotient is. So we have then f of x, so we have the limit as x approaches, my a is my point of tangency, so negative 1. F of x is 3 minus 2x, and then minus my f of a is given as an order pair. So had they just said x is equal to 1, like we do in number 4 and number 5, you would have to find f of a. So I have 5 all over x minus a negative 1. So I have the limit as x approaches negative 1 of negative 2x minus 2 over x plus 1. But I'm not ready to evaluate yet because that's going to make my denominator 0. So I need to factor the numerator. So I have negative 2 times x plus 1 over x plus 1. Obviously, those are going to go away. And I have the limit as x approaches negative 1 of negative 2. The limit of a constant is the constant, so negative 2 is still MTAN. Okay, so you get it the same way. Again, this one is much easier if you're only finding MTAN. So this is only useful if the only thing you're looking for is MTAN or the slope of the tangent line equation or whatever. So this one is only helpful in this particular scenario, which is fine as long as you remember the formula. So you have to remember that it's x approaches a. It's not a difficult formula, just a matter of remembering the formula, okay? Okay, so since the first two sections we use the derivative rule, in the event that you would like to use the other one, I'm going to go ahead and practice on this one as well. Okay, so we have then, this time I have a, so this is a, right? I need f of a for my formula. So if my formula is the limit as x approaches a of f of x minus f of a over x minus a, then I need to find f of a. So I'm going to go over here, find f of a. So I have 5 minus 2 squared. So that's 5 minus 4, which is 1. So I can plug into my formula, the limit as x approaches a of f of x, which is 5 minus x squared, minus my f of a, which I found to be 1, all over x minus 2. And this was supposed to sub in there, sorry, 2. Right? So then I have the limit as x approaches 2 of negative x squared plus 4 over x minus 2. So obviously I need to take a negative out in the top. So I have the limit as x approaches 2, negative 1 times x squared minus 4 over x minus 2. So I have the limit as x approaches 2 of negative 1 times x plus 2, x minus 2, all over x minus 2. So now I can cross those out here, which gives me the limit as x approaches 2 of negative 1 times x plus 2. So then I have the limit as x approaches 2 of negative x plus 2, which I can minus 2, sorry, which I can absolutely plug into. So I can evaluate my limit. So I have the limit as x approaches 2. Oh, no, I can evaluate my limit, which means I have negative 2 minus 2, which means that m tan is equal to negative 4. Okay? And I know on the answer key I found the equation of the tangent line. I just did that. Okay, it's good practice, but the next two actually ask us to find m tan and m normal, which I'll talk about in just a minute, and finding the normal line, but you didn't have to find the line, just find m tan. Okay? Okay, for this one, I'm going to go ahead and use the derivative formula simply because I want to practice taking the derivative with a radical in it. I think that's a good practice. So I'm going to do the limit as h approaches 0. So it's going to be of f of x plus h minus f of x all over h. Now I want to point out, if you want to use the one from the previous example, you can use that one. And as far as evaluating, it would be much easier to use that definition because we're only looking for m tan, right? So you can use that definition, but I'm simply going to use this one so that you can have more practice using the limit definition with a radical, okay? So I'm going to have f of x plus h is equal to x plus h plus the square root of x plus h, okay? So I have then the limit as x approaches, see, that's what happens when you switch between formulas. As h approaches 0 of x plus h plus the square root of x plus h minus the quantity x and the square root of x all over h. So the only thing that simplifies here is my x's go away. And then I'm left with the limit as h approaches 0 of h minus the square root of x plus the square root of x plus h all over h. Okay, so I'm going to work this one differently even than I did in the key. So in the key, I used the a plus h. So you have that example in the key. But here, I'm just going to evaluate it just like this. So this one is a little bit different because I don't have a conjugate that I can multiply by here because I have 3 terms in the top. So what I would do is break this limit apart. So I would have the limit as h approaches 0 of h over h, right? Plus the limit as h approaches 0 of negative square root of x. Let's write that the opposite way. It'd be easier to see the conjugate. So x plus h minus the square root of x over h. So literally, I just broke the fraction apart, right? Everybody with me? So to be clear, I just wrote this over this, and then I separated it with a plus sign. I just broke the fraction apart, okay? So that's going to give me the limit as h approaches 0 of 1, because anything over itself is 1, plus the limit as h approaches 0 of this. Now I can multiply by the conjugate, right? Because I have it as a binomial. So I'm going to multiply by the square root of x plus h plus the square root of x all over the square root of x plus h plus x. Plus the square root of x, right? Okay, so then when I multiply by the conjugate, we know a couple things happen. So I'm going to go ahead and evaluate this limit here. Okay, the limit of constant is a constant plus the limit as h approaches 0. So when we multiply by a conjugate, remember basically what you end up doing is multiplying the first term and the last term, because those two middle terms cancel out. It's the whole idea of multiplying by a conjugate. So we have x plus h, and then times the square root of x plus h, which would be x plus h. And the negative square root of x times the square root of x would be negative x, all over h times the square root of x plus h plus the square root of x. So I have 1 plus the limit as h approaches 0. So my x's are going to cancel and leave me with h over h times the square root of x plus h plus the square root of x. And then my h's cancel. And that gives me, I'm not in the right color, 1 plus the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. So that gives me, I'm ready to evaluate, 1 plus 1 over 2 square root of x. So this is f prime. Now, in order to find m tan, f prime would be equal to 1 plus 1 over 2 square root of x, and my x is here, 1. However, here we are. This is much easier. Much more difficult, but it is something that you need to know how to do in case it happens for you at some point. So that's why I did it this way, okay? So remember, m tan is equal to f prime at a. So m tan, so I have 1 plus 1 over 2 square root of x, and I want to evaluate that at 1, which gives me 1 plus 1/2, which means that m tan is 3 over 2. Now, I would like to point out one more time, it is much easier to do this in the formula here. Much easier if you're only looking for m tan. Okay, so this is only going to work if you're looking for m tan, which is what we're looking for in this problem. Totally legitimate way to do the problem. Will be a whole lot easier to evaluate it in that method. Okay, so before we get to number 6 and 7, there's one thing that I did not mention to you. We did not get to it yet in the notes. It's randomly in another section, but I always put it on this daily grade because I usually address it. So tangent versus normal line. So we know how to find the tangent line, right? We do m tan and the point, and we find the equation of the line, right? Normal is perpendicular to m tan. So if we know, we use the same point, but it's perpendicular to m tan. So for example, if m tan is equal to 3 over 2, okay? I don't know why I have that random mark. 3 over 2. And the point is 1, 7. We can take that slope and that point and we can find the equation of a line. So if we were going to find the normal line at the same point, we don't have to do any extra work. We know that m perpendicular or m normal is going to be equal to negative 2 over 3 because perpendicular lines, remember, have opposite reciprocal slopes. So it's the opposite sign and the reciprocal, and you would use the same point and you would find the equation of the normal line. So not any more calculus work, just a little bit more algebra. So the only calculus is knowing that the normal line is perpendicular to tangent. Outside of that, the rest is just algebra too. Okay, so same situation. It's not really asking us for the general derivative. It's simply asking us to find m tan and write the equation of the line, and then to find the normal line, right? So I'm going to use the limit as x approaches a of g of x minus g of a over x minus a. Okay, so I just use g because the function is listed as g, right? So I have a is 2, and then it gave me an order pair, so I know g of a is 5. So I have the limit as x approaches 2. So g of x is x squared plus 1 minus my g of a, which is 5, all over x minus 2. So clearly we can't plug in at this point because it would make my denominator 0. So I have the limit as x approaches 2 of x squared minus 4 over x minus 2, which conveniently factors. So I have the limit as x approaches 2 of x plus 2, x minus 2, all over x minus 2. So beautifully enough, these will go away. And I have the limit as x approaches 2 of x plus, sorry, I hit a button. So x plus 2, right? So we have, then we're ready to evaluate. This is linear. So then I know that m tan is equal to 2 plus 2. So m tan is equal to 4. So if I want to find the tangent line, so we'll do tangent first. I'm going to use point slope formula because it's the easiest for me. You can use y equals mx plus b, find b, and then rewrite the line. Doesn't really matter. But I'm going to use point slope. So I have, remember our point was given. So I have y minus 5 is equal to my slope times x minus the x coordinate 2. So I have y minus 5 is equal to 4x minus 8. Add 5 to both sides, and we get that the tangent line is equal to y equals 4x minus 3. So then to find the normal line, remember that it has perpendicular slopes, so that would be negative 1/4. We're going to use the same point. So I have y minus my y value of 5 is equal to my slope, negative 1/4, times x minus my x value of 2. So I have y minus 5 is equal to negative 1/4 x plus 1/2. Add 5 to both sides. And we get the equation, the normal line is y is equal to negative 1/4 x plus 11 over 2. Okay, so remember 5, if you get a common denominator of 2, that would be 10 over 2. And 10 over 2 plus 1 over 2 is 11 over 2. Algebra, not calculus, okay? Okay, so I'm going to work this problem finding the general derivative first and then plugging in, simply because, again, it has that radical, and you have expressed discomfort to me when you're finding using the limit definition with a radical. So I'm going to do it that way just so you have the practice. So I have the limit as h approaches 0 of f of x plus h minus f of x all over h. So I need to find f of x plus h. So that would be x plus h minus 1. So I have the limit as h approaches 0, the square root of x plus h minus 1 minus my f of x, so square root of x minus 1, all over h. So I have the limit. So remember, we are finding f prime here. That should be f prime equals. So I'm going to change this one. I should be writing that in the beginning, and I'm being lazy. So f prime of x is equal to the limit as h approaches 0. So my 1's are going to cancel, but that's it. The square root of x plus h minus the square root of x over h. So I cannot evaluate this limit as it sits. So remember, basically the only option you have at this point is to do the multiply by the conjugate. So I'm going to multiply top and bottom by the square root of x plus h plus the square root of x. Square root of x plus h plus the square root of x. Okay, so that's going to give me the limit as h approaches 0. So remember, again, when we multiply by conjugates, there's a purpose for that. It's to make those radicals disappear, to make an imaginary number disappear. That's the whole idea. They don't disappear, they multiply out, right? So first times first would be x plus h, and then last times last would be negative x over h times the square root of x plus h plus the square root of x. So I have equals the limit as h approaches 0. So my x's cancel and leave me with h over h times the square root of x plus h plus the square root of x. So then obviously my h's cancel. And that leaves me with the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. So I'm ready to evaluate. So that's giving me 1 over the square root of x plus the square root of x. So f prime is equal to 1 over 2 square roots of x. Now to find m tan, we evaluate f prime at your given value of 9. So 1 over 2 times the square root of 9 means that m tan is equal to 1/6. Okay, so now that I have m tan, I can find the tangent line. So tangent would be y minus my y coordinate. Oh, I don't have it, so I need to find f of 9. So the square root of 9 minus 1, which is 2. So that would be y minus 2 is equal to my slope 1/6 x minus 9. So I have y minus 2 is equal to 1/6 x minus 1/6 times 9 would be 3 over 2. We're going to add 2 to both sides, and we get then that the tangent line is 1/6 x plus 1/2. Okay? Now, if I want to find the normal line, so that's going to be perpendicular. So normal is perpendicular slope. So my perpendicular slope would be a -6. So reciprocal and opposite. My point was 9, 2. So I have y minus 2 is equal to -6 times x minus 9. So y minus 2 is equal to -6x plus 54. Add 2 to both sides. And we get that the normal line is -6x plus 56. Okay? Okay, so basically this is giving us a function that's already in the limit definition formula and asking us to find what the original function is. Okay, so to do that, you may want to review what the formula is. So let's look at the formula. So this is f of x plus h minus f of x over h. So this one is pretty straightforward, right? So this is f of x. So this is f of x. So that means that f of x, wrong button, f of x had to have been x squared. Easy enough. Same thing here. If you know your formula, you have f of x has to be equal to the second part of the equation because that's the formula, right? So f of x has to be equal to 2 square root of x. One thing that I would caution you on is paying attention to the sign because they might throw in a plus sign there, which would mean this would be negative, right? So just caution, caution, caution. So same thing here. We have the formula. It's straight into the formula. There's still x's in there, no values. So f of x has to be the second part of that formula, what comes after the minus sign, which is sine x. Now these are a little bit different because it's not just the formula. They've already plugged in a value, right? So we have to figure out what formula it is they used here. So what they did was use this formula. So f of a plus h minus f of a all over h, right? So let's think this through logically. Okay, so this value is the output of plugging in a, whatever a is, right? So what they did was they replaced everything in the original function here. So this is this, and this is this. So remember how do we find that? Well, everywhere we see an x in the original function, I'm going to replace it with a plus h, right? So that means that my original function, f of x, is 5 minus 3 times x, because this here right there, that 1 plus h, is my a plus h, which means then that my a, I keep doing that, my a has to be 1. So let's go back over this again. So let's say that I was given this information. Okay, so then to find f of a, I would plug in 1. So 5 minus 3 times 1 is 2, which is where they got this 2, right? If I wanted to find f of a plus h, I would plug in 1 plus h everywhere I see an x, which would be 5 minus 3 times 1 plus h, which is what's in the problem. Okay, so you're just kind of thinking backwards. So last, it's the same type of problem. So what we're looking at here is this formula. Oh, that should be A. Already plugged into, right? So that means that this section right here is what I'm focused on because it tells me the most about the function because all I did was replace x with a plus h, right? So my f of x, and I keep doing that, my f of x had to have been x cubed because this is a plus h there. So that means a is equal to -2.